Hello, class. Let's see here. We are going to work on gravitation tonight, and I'm just going to go ahead and navigate to that particular um, site on STEM physics. You'll notice that all I'm going to have are instructional videos as well as a submission link. It is in level 6. So you'll see gravitation right here. And I will have notes in here, so I'll change these videos out. And yeah, let's work on this right now, okay? So I'm just going to go to, let me close that. I'd like to go here. And I want to talk about the theory, of course. So theory helps guide the experiment helps guide the theory, on and on and on. So I'm going to talk about fields. And in this case, we're going to talk about gravitational fields. And what are fields? Fields are non-contact forces, okay? So fields are non-contact forces. All right? So we have the gravitational field. You don't have anyone wrapping their hands around you in order to pull you down. So we call that, we don't necessarily refer to that as a contact force. It's a non-contact force. So we refer to it as the gravitational field. So what I want to do here is I want to describe what's happening. And we have a law. And this law is called the universal law of gravitation. Okay, and the law looks like this. It says F sub G is just equal to G, which is a universal gravitational constant, proportionality constant. In other words, you find it in the lab. You have to find it empirically. It's not an analytical thing. Equals to M1 times M2 over the distance between the two objects squared. So let's just look at a picture here. So the distance between the centers of these objects, that's going to be our R. So whatever that measure is, okay? And then this object on the left, we're gonna have to say that that's M sub 1, and we have another object on the right, that's M sub 2. So we know those masses. If you can put them on scales, you know the masses. And then of course we have G, but that's again just a constant. And F sub G is a force that acts along the line contacting, not contacting. F sub G is the force acting along the line connecting the two objects. All right. If F sub G acts on M sub 2, then M sub 2 is going to act on M sub 1 the same way. So I kind of said that a little weird, but if M sub 1 exerts a force on M sub 2 is going to exert a force back on M sub 1. So that's Newton's third law, action reaction. So this pretty much describes what's happening here. We have our force here. These two forces are equal to this. Okay, and then we have M sub 1 right here, and we have M sub 1 right here. So you just have to be able to put that information in. And then we have M sub 2 and M sub 2 right here. All right, and then we have R. Right here, and we have R right here. So those are where those values go. So you have to be able to measure them. So this is the universal law of gravitation. This is called Newton's universal law of gravitation. It's sweet. Let's understand this, okay? It's going to be the basis for us to go into electricity and magnetism, all right, as far as some of the models that I'm going to use. Of course, there are newer models out there, but we're going to use some different ones, okay?